Kia ora Year 12, this is lockdown video 2, and in this video I'm going to go through a really simple tree diagram example, and it's designed to help you with the Walker book questions on trees. And if you haven't got the Walker book at home with you, I'm posting some of their extra worksheets that you're allowed to use on Google Classroom. So this goes with pages 54 onwards in my edition, and the page numbers might be slightly different in your newer one. So what I want to especially focus on in this video is how to figure out how to find conditional probabilities from a tree diagram. So we're going to start out with a tree diagram that is based on real life in lockdown. It's all about me, coffee, and my dog Bonnie. So this is what the tree diagram is going to look like. I'm just going to draw it in as I talk it through. So when I get up in the morning, I either can have coffee or no coffee. And you'll know from video 1 that we write that not coffee, just with this dash. So that means no coffee, the complement of coffee. And as you all know, most of the time I'll have coffee. So we'll make that 0.9, and that means that this one here must be 0.1, right? So those numbers have got to add up to 1. So if I've had my coffee most of the time, I will take Bonnie for a walk. So we'll just put walk dog, and that happens 80% of the time, so 0.8. And then I'm just going to put walk dash for don't walk. But if I don't have my coffee, I'm much less likely to take her for a walk. So we've got a 0.6 probability that I walk Bonnie if I haven't had my coffee, and a 0.4 probability that I don't walk her. Walk dog, don't walk dog. So straight away you can see that I haven't put all the numbers in on purpose, but we know that they have to add up to 1, right? Either I walk the dog or I don't walk her, so that's going to be 0.2, and this one here is going to be 0.4. So what I've done here is I've just written some really simple probability questions that we're going to have to find, so that we get used to figuring out what the very subtle differences are in wording. So what's the probability that on a randomly chosen day I walk Bonnie? So question 1, let's look at what those two situations are. So either coffee and walk Bonnie, or no coffee and walk Bonnie. And you'll remember from the revision we did last week that all we have to do to find these probabilities is that we multiply down the branches, right? So thinking about it just from common sense, 90% of the time I have coffee, and then 80% of that time I walk Bonnie. So we times them together, and that gives me 0.72, right, or 72% of the time. And we do that for all 4 outcomes. Okay, so coffee and not walking Bonnie is going to have a probability of 0.18, and then not having coffee and walking Bonnie will be 0.06, and lastly not having coffee and not walking Bonnie, which must mean that I'm really, really ill, would be 0.04. So if I want to find the probability that on a randomly chosen day I walk Bonnie, all I have to do is to add up this one here and this one here. So just watch the notation that I use. It's going to be P bracket, whoop, wrong pen, P bracket walk is equal to 0.72 plus 0.06, which gives me 0.78. Okay, what is the probability that I walk Bonnie and have coffee? So that's very easy from a tree. So it's walk and have coffee. Remember this notation I talked about in my first lockdown video. So walk and have coffee is simply that top tree branch. So let's get rid of that one. Oop. Okay, so it's just the one up here, coffee and walk. So that's pretty simple. That's 0.72. Okay, number 3, what's the probability that I walk Bonnie or have coffee? So when we talk about this in probability, we mean that I either take her for a walk, or I have coffee, or I do both. Okay, so probability of walk or coffee, which sometimes you'll see written with that symbol, okay, walk or coffee is equal to 3 things, right? So it's the probability that I have coffee and walk her, or here coffee and don't walk her, and then I don't have coffee but I do walk her. So I just have to add up those three probabilities. You can see that the smart way to do that is to say, well, the 90% of the time when I have coffee is going to be in there, and also this one pathway here, right? So I can either add up those three numbers separately, or I can just add up this number and this number here. Okay, so the probability of walk or coffee is equal to the 0.9 plus the 0.06, which is 0.96. Okay, on to question 4. So have a look at it, and hopefully you'll see that it's a conditional probability one. Right, so on a day that I have coffee, what is the probability that I walk Bonnie? Just trying to clean up some of this huge mess before we go any further. Right, so on a day that I have coffee, what are the chances that I walk the dog? And you can see that I can read that straight off the tree diagram, right? Because when I have a tree diagram, these probabilities here, so these ones here and here and here and here are conditional probabilities, right? So on a day that I have coffee means go to the end of that branch and then say, what's the probability that I walk her? So the answer is going to be simply 0.8. So probability, given that I have coffee, the probability that I walk Bonnie is 0.8. But the other way that I could get there is by applying the formula or the definition that I gave you in the first video, which is this, that when I've got a conditional probability, I'm only interested in the times when that thing happened. So event B, and then I want to know when both of those things happened. So in this case, it's like saying, well, tell me the probability that I drink coffee, and then tell me the probability that I both walk the dog and drink coffee. And as I said, you can read this one straight off the tree diagram, but we could easily see that it fits our formula, right? So we've got 0.72 here, which is the probability of walk and coffee, and the probability of coffee is 0.9. Right. Okay, then the next one is the other way around, and this is where we do need to use the formula, and this comes up quite early in the Walker book. So just be on the lookout for it. Given that I walk Bonnie, what's the probability that I have coffee? So this is a conditional probability. Given that I walk the dog, what's the probability that I have coffee? And this time we don't know straight away from the tree because it's the wrong way around, right? This time I'm saying, given if I take her for a walk, what are the chances that I'm back here? So it's kind of like going backwards on my tree diagram. So this time I have to work out the probability of coffee and walk divided by how often, or the probability that I walk her. So we have to do a little bit more work for these ones. So the probability that I take her for a walk is coming from two different places in here. It's this one here and this one up here. So there's one of the walking probabilities, and there's the other one. So the probability that I walk her is equal to 0.72 plus 0.06, which is 0.78. Okay, so that's going to be my denominator. And up here, the probability that I have coffee and walk her is 0.72. So that gives me 0.923 for my final answer. So that was quite long, and I've gone slowly through that, but that's going to come up quite a lot when you start doing the Walker questions. Remember that I've also put full word solutions up for those, so make sure you're using those as well, and they are up on Google Classroom. So the next video that I'm going to do is going to look at what we do when we've got what we call sampling without replacement. But first of all, I think about the first 5 or 6 Walker questions are basically what I've done in this video, done in different ways. So thanks for watching, and just email me if you've got any questions or concerns.